All right, so when we first started out, okay, we started out with chemistry. Okay, now in terms of like the atomic models and the people, that's pretty minor stuff. Okay, like read that over once, be done with it. Okay, it's not all that important. You know, like protons, neutrons, and electrons, and you know, basic structure of the atom stuff. That's fine. Okay, but the next thing that we went over was naming. Is naming important? Yeah, because without naming, you can't do basically anything else in this unit. You can't get a mole equation question right because you can't write the formula correctly. Okay, you can't balance an equation because you're not writing the formulas or getting the names right or whatever. Okay, so definitely naming is important. Naming chemical compounds, not calling people names. That's different. Okay, so naming chemical compounds. Well, we got ionic compounds, we got molecular compounds. If we're naming an ionic compound, metal first, non-metal second. And the non-metal will end in "ide." Okay, that's for ionic compounds. And ionic compounds never have what? No prefixes. But they might have polyatomic ions. Okay, so they could have something like nitrate. Okay, if it doesn't end in "ide," it's probably a polyatomic ion. All right, so be on the lookout for that. Okay, don't confuse nitrate, NO3, with nitride, N, right? Because that's a common thing that I see. All right, so make sure you're looking for your polyatomic ions. And also remember when to use Roman numerals or what they mean. Okay, Roman numerals get used in the names of an ionic compound if the metal has more than one possible charge. Okay, prime example could be something like, let's say, nickel 3 oxide. Okay, it can be. Sometimes I do it, sometimes I don't, as long as the Roman numeral is there and small. Okay, all right, so we got nickel 3 oxide. So if I want to write the formula for nickel 3 oxide, the Roman numeral tells me what? Nickel has a charge of 3. There are not 3 nickels. That's 15 cents, not what we're looking for. Okay, that went right over most of your heads. It wasn't all that funny anyway. Okay, so it has a charge of 3 plus. All right, oxide is always a charge of -2. All right, now what do I do with those charges? Drop and swap. Okay, so the 3 comes here, the 2 comes here. I can't reduce that, so there's my formula. All right, if that works in reverse, okay, I give you the formula and you have to go to the name. Let's see. No, sorry, I want to think of one that's a little tougher that actually has this exception in it. I just used one. There, that's one that'll work. All right, so I've got Pb, which is lead. Lead can be a 2 plus or 4 plus. Okay, and oxygen is always a -2. So I've got to figure out which Roman numeral I'm going to write on lead because I know the name is going to look like this. Lead something oxide. All right, so in order to figure out which Roman numeral, I use the non-metal because the non-metal only ever has one possible charge. So every oxygen has a -2 charge, and there are how many oxygens? 2. All right, that means this compound has a total of 4 negative charges. That means since I only have one lead, the charge on that lead has to be 4 plus. Okay, so then this is lead IV oxide. All right, is that ringing a bell? because I'll probably have some questions that involve metals that have Roman numerals in them, okay, as part of like, here's a reaction in words, write it out, or predict the products of this reaction, and you might have one that's got Roman numerals in the name, so you would have to write it correctly. Okay, so it's something to review if you don't remember. No, you will not, but I'm not going to go higher than 4. So IV is 4, and the others are just the number of I's. Yeah, should be good then. Okay. Okay. Yeah, Kelvin? I did not put the prefixes on there, but if you were desperate, you could ask me. Okay. I mean, I don't think I'm going very high with the prefixes, so, Petra, Penta maybe. Yeah. Okay. All right, so after naming, okay, then we talked about solubility and the polar nature of water. No. This is still chemistry. Okay, solubility and polar nature of water. Now, polar nature of water is more going to be tested in the biology unit because it's part of what? Okay, what about trees? Not so much reverse osmosis. Yeah, transpiration and how plants transport water from their roots to their leaves. Remember that, okay, we need the polar nature of water to keep the water attached to the inside of the xylem by hydrogen bonding. Okay, so that's more where that's going to come up as opposed to having a question in the chemistry section about it. Okay, that's more of an application of it, so that's more where it's going to be. Just make sure you remember how hydrogen bonding and polar molecules work. Henry. Okay, here's what you're getting on your test. Okay, this is your data sheet. Your periodic table has the special elements highlighted already by color. Yellow is 2s, okay? Blues are 4s and orange is 8. Okay, and it says that up top here. Okay, you got on the back a solubility chart and the formulas that you will need. The mole equation is here, Avogadro's number is here, the heat capacities that you'll need for the final exam are here, all the physics formulas are here, MLF, MLV, MC delta T, all of it is there. Okay, so that is your data sheet, and it'll just be tucked in with your exam package on the desk. Okay, Jake. It is, yes. The multiple choice is all by unit, and so is the written for the most part. There's a couple of questions that overlap more than one unit. Okay, so just be aware that there are a couple of those, but mostly it goes by unit, and the multiple choice goes entirely by unit. Okay. No, molecular compound. No, sorry, I skipped that, didn't I? I just talked about ionic. Okay, sorry. Molecular compounds. Remember, we don't balance the charges, right? In a molecular compound, you get the prefixes. Okay, so for a molecular compound, I might have like this, right? N2O3. That would be dinitrogen trioxide. Okay, what if I had this? Dinitrogen monoxide. What prefix do you never use on the first one? Mono. Okay, so we remember that. And then if I give you the name, okay, and you have to write the formula, you just use the prefixes, right? If it's di, it's 2. If it's tri, it's 3, and you don't have to do any dropping and swapping. Right. Okay, the highlighted numbers, the 2s and the 4s, that's when it's by itself. So it's more for reactions, right? Like a single replacement reaction where you might get one of those being alone. You have to remember it's a 2 or an 8. Yeah. You can't. Yeah, you can't balance molecular compounds. So that's why most of the reactions we dealt with produced ionic compounds, right? With the exception of a combustion reaction, which always produced the same 2 things, right? Yep, it's the same formula sheet you had before, right? So it's that table of polyatomic ions on top. No, they're combinations. Right, so this is right, that's a polyatomic ion, that's nitrate. This is iron 2 nitrate. No, you can't. No, it'll only be, yeah, sorry, you're right. Most of the polyatomic ions, remember they're ions, so they're only going to be part of an ionic compound, okay, are negatively charged. The exception is ammonium, which has a +1. Yeah, so no, they won't be in a molecular compound. They're by their nature ionic. Okay, so solubility. Could be some questions like you had on your unit exam. Here's a reaction. Tell me which of the products, if any, are soluble. All right, so you got to go back to your solubility chart, right? Look up the negatively charged ion on the top, and then go down the column, right? First row, it's soluble. Second row, it's not soluble. Okay, so look something like this. Okay. So soluble was first row, not soluble was the second row. So if we're looking at, let's say, trying to think of one that'll work here. So let's say for chlorine, okay, you would say soluble with like most, and then down here would be like lead and whatever else it's not soluble with. Okay, so if I had lead 2 chloride, I would go, oh, well, that's not soluble. That's going to be a precipitate. Okay, is that ringing a bell? No, lead chloride would be a precipitate. Okay, when lead is with chlorine, it's not soluble in water. Right, creates precipitate. No capitals, although I see that being less of a problem. Yeah. Picture of an element. Oh, like asked to draw one, like you were on your unit exam? There's going to be some structure of the atom stuff, but probably not like that. Yeah, there could be some properties of compound stuff in there where I, describe something. You have to, probably not as specific, okay, but I might ask about properties of ionic compounds versus molecular compounds, right? Like the conductivity test or something like that. But yeah. There's some structure of the atom questions. Yeah. Mm-hmm. I'm not trying to dissolve chlorine into lead. This is the result of a reaction. So I had sodium chloride reacting with lead 2 oxide. Okay, the products are lead 2 chloride and sodium oxide. Okay, which if any are soluble? That's not. That is. Is not soluble. That's going to become a solid product on the bottom. Okay, like when we did the lab and we produced the yellow one, remember the bright yellow precipitate? That was lead iodide. It's also not soluble. Lead's not soluble with very many of the halides. Okay, so that was a bright yellow precipitate. Okay, that compound. So the yellow powder was lead 2 iodide. It is not soluble in water. It's not like I don't know if chlorine is soluble in lead. Right? I'd have to melt lead and then bubble chlorine gas through it and see if it dissolves. I probably wouldn't. Right? You follow me there? It's kind of an artificial situation. No, it would always be a compound. Basically, as soon as you react and put an element in, it's reacting with stuff in there and creating compounds that are soluble or not. Yeah. Okay, so just again, this is only one way to explain it. I look on top for the negatively charged part of the compound. In this case, it was chlorine. Okay, and then I look in the rows. So I go down its column. If what it's paired with is in the first row, then it's soluble. If it's what it's with the second row, it's not soluble. Lead is in the second row, so this compound is not soluble in water. Okay, if like Na would be up here. Well, Na, and when it's sodium chloride, that is soluble. It's salt, it dissolves in water easily. Yeah, does that make sense? All right, and then since we're talking about reactions, big marks. Big marks on the final exam to do with reactions. If you're only going to study one thing from chemistry, make it reactions. okay? Because I'm going to have some questions where you're just balancing, right? So I give you the reaction and you balance it. So just fill in the blanks. I'm going to have some that are, here's a whole reaction written in words, write it out and balance it in formula form. And then I'm going to have a couple where it's, here's the reactants, predict the products in balance. Okay, those are exactly the same things I asked you to do in class, and I'm going to ask you again to do them on the final. All right, what are the 5 reaction types? Okay, so we got combustion, and let's just focus on combustion right now. Does it have a bunch of special rules? Okay, so combustion reactions start out with, and this would just be an example, okay, C2H6, okay, plus oxygen gas. It's always going to be a hydrocarbon reacting with oxygen, always. And what are always the products? Water and carbon dioxide. Okay, when it comes to balancing, are there special rules? 2 of them. Yeah, balance it alphabetically and right, the rule of 2, okay? In this case, carbon's an even number, so I start my balancing with a 2. 2 times 2 is 4, so I've got 4 carbons over here. 2 times 6 is 12. 6 times 2 is 12 hydrogens. And now I'm going to balance oxygen because it's last alphabetically. There are 6 oxygens here in the water. There are 8 more here. That's 14. What times 2 would give me 14? Okay. If I have an even number of carbons, I start my balancing with a 2. Then you don't have to. You can go with a 1. Okay. All right, so combustion. What's another one? Synthesis reaction. Okay, in a synthesis reaction, 2 elements combine to form a compound. Okay, so that would be a synthesis reaction. Sodium reacts with chlorine to produce sodium chloride. All right, what's another one? Single replacement. Okay, and single replacement is the one that has the most things you have to watch for. Okay, because you could get special elements being produced. Okay, in the products part. Okay, things like that. So let's say we've got I don't even know if this is a real reaction, but we'll write it. Okay, phosphorus reacts with magnesium chloride. Okay, so it's a single replacement reaction. Who is phosphorus going to replace? Chloride. All right, so we're going to have chlorine by itself and magnesium with phosphorus. Okay, is that special? Yes. All right, this is a -3, right? Yes. Yep. And magnesium is a +2. What do I have to do with that? Drop and swap. So there's another thing we have to be aware. When we produce an ionic compound, which we're always going to, we have to drop and swap it. Okay, now I've got everything written. I've got to balance the whole reaction. So let's start with the biggest number. I've got 4 phosphorus over here. Now I have 4 phosphorus over here, but that gives me how many magnesium? 6. So I got to go back over here, make sure I got 6 of those and 6 of those. Okay. Okay, what's another kind? Double replacement. Okay, double replacement is all ionic compounds. So we could have okay, hydrogen sulfate reacting with iron 3 hydroxide. So the 3 is outside the brackets. Yeah, it definitely is outside the brackets. All right, so what do I do with the metals here? I swap them. That's going to make my 2 new compounds. All right, so I'm going to have iron ending up with sulfate and hydrogen ending up with OH. Sweet, water. Okay. No, I said they're all nonmetals. or all act like nonmetals, except for ammonium, which acts like a metal because it's positively charged. Yeah, whenever ammonium is involved, ammonium is a metal. Yeah. Okay, so now I've got to check my swaps and drops. What was the charge on iron over here? 3. Okay, and you got to watch for that with with multivalent metals. Okay, so the charge on it is 3. The charge on sulfate is 2. So we got Fe2, SO4, 3. All right, so that's where the brackets come in. I just picked it. Yeah, but remember, OH has a -1 charge. This is iron with the 3+. Yeah? Okay. All right, and then the water's good because it's -1 and +1, so I don't have to do any brackets or anything else there. All right, now I've got to go back and balance everything. Present in the highest number right now is sulfate. Okay, there's 3 over there. So we can try that. We'll put a 3 here. Okay, that'll give me how many hydrogens? 6. Okay, so I'm going to put a 6 there. 6 hydroxide, so I got to put a 2 here. Hey, that worked. Okay, because now I've got 2 irons on both sides. All right, wasn't lucky. Skill. No, 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 no. You're going to get basic reaction type balancing questions. Yeah. Okay, remember, the final exam tests a lot of things. So the level of difficulty is lower because there's lots of stuff, right? Level of detail on the last unit exam, very high because there's very little material, right? It's the exact opposite of the final exam. Yep, there's definitely a climatogram on the final exam because climatograms are one of the few things that was in that unit. Like basically, if I tested it in the written response on that test, it's going to be in the final exam. Okay. Like this one? Yes. Yeah. All right, and we're missing one. Decomp, I think, is the only one we haven't done, right? All right, so in a decomposition reaction, we have some kind of a compound breaking down. It's usually going to be ionic so that you can accurately predict what the products will be. Okay, so let's say it's, I don't know, all right, potassium nitride breaks down. Okay, so I'm going to get potassium and I'm going to get nitrogen. Do I have any specials? All right, and we're good. Okay, so definitely spend some time going over that. A really good way to go over that is you had, I think, 4 quizzes on reactions. Okay, 4 quizzes on reactions. So go back into Power School, click on those quizzes. Okay, and when you open them up, you'll see 2 links. Okay, one that says podcast 4 questions, and then you click on that, takes you to the questions, and then podcast to quiz 4, click on that, it's me going through the solution with you. All right, so good way to review and see if you know those. Right, in an ionic compound, the charges always have to balance. Well, yeah, because they're sharing the electrons, not trading them. Yeah. Okay. And then last thing, guys, okay, I mean, because we've talked about all the different ways I can do reactions, there'll be balancing, writing, predicting, okay, and then we got moles. N equals little m over big M, okay? N is the number of moles. Whoa. Okay, M is the mass. Little m. Okay, and N is moles. Ironically, the only thing that actually, well, they all start with M. It's just dumb. Anyway, okay, that's chemistry. So, mole equation question could ask you something like, okay, could go something like that. I probably wouldn't pick a compound that brutal, but okay. That's what I'm going to go with today, just so we can review a couple of other things at the same time. All right, manganese 4 oxide. How important is it for me to get that formula right? It's crucial. If I don't get the formula right, I'm not going to get the molar mass right, and I'm not going to get the rest of the question right. Okay, so got to write the formula for manganese 4 oxide. All right, so manganese is Mn, and the Roman numeral tells me it's +4. It's with oxygen, which is a -2. So 2 and 4. Reduce down to 1 and 2. All right, so MnO2 is our formula. So now we got to calculate our molar mass. I have no idea what the molar mass of manganese is, because I have to reduce. Okay, it was going to be 4, and it was going to be 2 and 4, right? Because I would have brought the 2 here and the 4 there, but I can't leave it as 2 and 4. I always reduce to the lowest terms in an ionic compound, always. Okay, it's one of those. That's why I wanted to. That's why I chose that one. It was something that we hadn't talked about for a while. Okay, all right. So now I forget what manganese was. 54.94. Is that what you guys have? Okay. 54.94, not times, plus 2 oxygens. So that's 32, because each oxygen is 16. $53.94 plus 32. Okay, so 85.94. It's 54. So 86.94. Put the eraser back in the eraser spot. Grams per mole. All right, so I got molar mass. If I'm going to find mass, I'm going to need N, and I'm going to need big M. I have big M, but I don't have N. How can I find it? I don't want to multiply. I want to divide. Okay, I want to divide the number of molecules by the number of molecules in 1 mole to leave me the number of moles, right? I would multiply if I was trying to find the number of molecules. Okay, in this case, okay, the number of moles is the number of molecules divided by Avogadro's number. Okay, in the same way that if I asked you how many dozen are there in 48, you would go 48 over 12. Okay, it's 4 dozen. All right, so that's what we're doing here. Okay, so I'm going to take my, was it 5.6 times 10 to the 25 and divide it by 6.02 times 10 to the 23. Yep, that's on the test. All right, so I've got 93 moles of this stuff, 93.02 moles. Should you keep all the decimals? Yes, till the end, right? Okay, 93.02 moles, and now that I have N, I can multiply by by the molar mass, which is 86.94. Okay, so I'm just going to take that number with all the decimals, 86.94. Okay, so that's going to have a mass of almost over 8 kilograms. Okay, 8,087.44 grams. So it's a lot. If I'm looking for the number of molecules. So I would have the number of moles, and I multiply by the number of molecules in a mole, Avogadro's number. That will give me the number of molecules, right? Because moles cancels. Okay, Avogadro's number, okay, the 6.02 times 10 to the 23 is like particles per mole, right? So when I was dividing particles by particles per mole, particles canceled, and I was left with moles. With me there? Okay, if I multiply, I'm going to take N, which is moles, and multiply by particles per mole. Moles cancel, left with particles. Yeah? I think you're overthinking that one. Okay, I multiply by Avogadro's number if I'm trying to get a big number, right? If I'm looking for number of molecules, that's a big number, right? So I want to multiply to get a big number. Particles, yes, because they're a particle. This could, Well, atoms are a particle too, right? So if I got, if it said how many sodium atoms are there in 20 grams, then that's why we have to use particles here, because it could be atoms or molecules. Most of the time it's molecules. Yep. Okay, Alex.
What did you do after you got 93.02? Is that what you were looking for?
No, sorry, that was, I'm looking for mass. Sorry. So then I multiplied that by the molar mass, 86.94. Okay. That's the answer. Okay, so I took this was 93.023, that was my number of moles, that's N. And then 86.94 was my big M, my molar mass. So I multiplied those two together, and that got me the 8,087.44 grams. Say that again? No. If you're looking for moles, you divide, because that's the way the formula is set up, right? N equals little m over big M. If I'm looking for number of moles, I divide mass by molar mass. Okay? Jake? Right. Yep. There's two ways, but it depends on what you're given, right? I have to do it this way if I'm given the number of molecules, because I won't know the mass, right? Okay, any other questions on the mole equation? Okay, because there's going to be a couple of those for sure on your final exam. So make sure you go over those. You got a bunch of quizzes on that. I think we had 3 on that. Okay, and every day for 4 days in that unit, did I go over every way I could ask a mole equation question? How many were there? 4. Okay, so there's like 16 examples of how to do a mole equation question in the podcasts, okay, from the chemistry unit, right? So not a bad idea if you're looking for that to go over that one.
Where do you get the 32?
That was 2 oxygen atoms. Each oxygen is 16. Yep. Okay, any other questions on that one? Okay, that's chemistry, all right? So study your notes, okay, but mostly practice your skills, because that's where the big marks are. Being able to write, predict, balance reactions, and do mole equation calculations. Those are the big ones, because those are the ones you really got to be able to do when you get to Chem 20, because right away you start reaction stoich, okay? And you're going to do that right away, okay? All right, so that's the quick and dirty review of chemistry, okay? Now, okay, biology unit, cell theory. What am I going to ask about cell theory? I might have a multiple choice question about the 3 points of the cell theory. Okay, all organisms are made of cells. Cells reproduce by dividing, and cells carry out the basic functions of the organism. How many times can you work that into an answer? Yeah, I mean, it's pretty important. That's what cells do, especially if you're talking about cell transport. And especially if that question has to do with cell size, because we kind of talked about that a lot. Okay, cells mostly use what process to transport materials? So if they're using diffusion, getting too big is going to be a problem, because diffusion works over small distances. It's really slow though, right? So it doesn't work well over big distances, and it's not targeted. So it can't just say, I need to send that stuff there. It sends out 100 of them in hopes that 2 of them get there. Okay? And the bigger the cell is, the less chance of that happening there is. All right? Okay. So cell theory, yeah, make sure you know like the 3 points, especially the cells carry out the basic functions part. Okay, cell transport's big, right? And what are the 3 ways? We already talked about diffusion, osmosis, active transport. Okay, active transport is the one that uses energy and pumps things with the little transport proteins across the membrane. Right? I am not worried about receptor mediated and phagocytosis and pinocytosis. Okay, the big 3. right? The big three are important. You had a written response item on each one on your biology exam, okay? So chances are you're going to see probably 2 of them here, okay? So make sure you know that cell transport stuff. And so we talked about diffusion. Diffusion is important to do with cell size. Active transport is the one that uses energy. It goes against the gradient. Osmosis is the kind of the most, I wouldn't say most universal, but it gets used for a lot of different things, okay? Especially when it comes to plants. Okay, that's, yeah, remember the osmosis happens because as water evaporates through the stomates, salts get left behind. Okay, water wants to balance the salt concentration, so it moves up the xylem, okay, using the polar nature of water and that osmotic pulling force from above. That's definitely something you'll need to explain, okay, on your final exam. Layers of the leaf. Should we know those? Yeah, for a couple of reasons. First off, it's how a plant works, and secondly, it has to do with this. Right? Specialization was kind of a big deal when we were talking about eukaryotic organisms and multicellular organisms. Okay, having all those different organelles allows you to become specialized and do particular jobs. So like the stomate, okay, was an example of a very specialized cell, the guard cell that is on the stomate, the palisade layer, the spongy layer, right? All that kind of stuff. So make sure you go over that as well. Yep, it does. But the reason it's going to the leaf to transpire is because there's an osmotic pulling force there. Yeah. Jake.
What's the difference between a eukaryote?
Presence of organelles. Right? A eukaryote's going to be generally bigger. Nucleus, mitochondria, yeah, all that stuff. Whereas a prokaryote's not going to have that stuff. Okay. Compartmentalization. Yeah, you should know about that. I'm going to have a diagram of a cell. Okay. It's in the multiple choice this time, but okay. No, it's in the multiple choice this time. So make sure you go over your cell diagram. You need to know what the parts do and what they are, because there are some questions on that for sure. Bernardo? Yes, yeah, I know. Yeah, I knew we were going to run into. My hope was we'd get through chem and bio today, but we can continue bio and do physics tomorrow. And you know, but it's a short class, right? So I figured I'd only get through 1 unit tomorrow. Bacteria will be virtually absent, other than like what's a prokaryote. Yeah. Okay. So tomorrow, guys, I'm going to try and like jet through the rest of the bio unit. There's really not much more to talk about. It's a few concepts in different ways. I'll go through physics quickly and then take questions. Okay. So come with questions tomorrow. Well, no, because we just did that. I just reviewed it on Tuesday. Well, if we have time, or you can, that can be your questions if you want. Okay.